Today we're going to be talking about graphing linear functions. Now when graphing linear functions, we first have to cover a little bit of vocabulary. For example, a linear equation is an equation whose graph is a line. As you can see right here, I've given you an example of that. The solutions of a linear equation are the points that make up a graph. As you can see, there are multiple points here on the graph, and there are also many more that have not been actually graphed on this graph equation. The linear function is a function whose graph is not a vertical line. Remember, a vertical line goes straight up and down, whereas a horizontal line lies flat, kind of like the horizon. I've given you a few examples here on the screen. As you can see, a function can have a positive slope, a negative slope. It can be in the top half, bottom half, or even the left or the right part of the graph. There is no exact as to where it has to be or where it lies. The only thing that it cannot be is a straight up and down vertical line. So let's give this a shot and graph one of these. It says graph the linear function y equals 3x minus 3. I have created an input table just like we did in the previous lessons, where we have our x, our rule, and our outputs. And then I've created an extra column where we're going to put our ordered pair. Now, here I get to choose my x's. So I chose a -1 to start off with. Remember, I rewrite the equation exactly as it looks, taking out only the x, and I replace the x with my input, the x that I've chosen. So here I've got 3 times a -1. 3 times -1 is -3, so I have -3 minus 3. If you remember our rule of keep it, change it, I'm going to have -3, change my minus to a plus, and change my +3 to a -3. That will make it -3 plus a -3. Since my signs are the same, I will add and keep the sign, giving me a -6. Then I take my x and my y and make my ordered pair of -1, -6. Next, I chose to pick 0. Again, rewriting my equation, taking out only the x and replacing it with 0. So I'll have 3 times 0 is 0, minus 3 is -3. And then I take my x and my y and make an ordered pair of 0, -3. I then put in a 1. 3 times 1 is 3, minus 3 is 0, and I get my ordered pair of 1, 0. Now, I then need to graph this. Well, let's graph that first point here, -1, -6. I start at my origin. The -1 tells me to move left on the x-axis 1 unit, and then down 6. And I put a dot right there. The second point, 0, -3, tells me to stay put on the x-axis, and then to move 3 units down, so I would put a dot here at 0, -3. The final point, 1, 0, tells you to move 1 right on the x-axis, and then stay put at 0. And I would put a dot right there. Now, as you can tell from our previous lessons, we have these dots, and it looks like they're lying in a line right here, and you can actually tell something with that data. Well, I can actually draw a line right there, and voila, our dots magically come into line. And if you were to follow this line straight up, you're going to see I would probably have another point right here at 2, 3. And if we continue our table, I'm sure you're going to find the exact same thing there, as well as another point here at 3, 6. Like I said, if you were to continue your table, you're going to find that that actually does continue on. Let's try another example. This time it's a word problem, and I'm going to use our unravel lesson that we talked about yesterday. First, I'm going to underline the question, or what you're supposed to do. Remember, if I told you yesterday, it doesn't always end in a question mark. Sometimes it's actually going to end in a period as to what you're supposed to do. And you start at the period, and you're going to move backwards until you hit the next capital letter. Well, when I do that, I actually see that the next capital letter is the word then. Then signifies to me that I'm supposed to be doing something else, not just one thing. So I'm going to go back to the next capital letter where it says the word write. Write a linear function that describes the movement of the plates over time. Then make a graph over 4 years. Now predict In is now predict what you think you need to do to solve the problem. Well, I'm predicting I'm going to need to write a linear function and graph it. But I don't have enough information in that statement to what I need to do. Okay, so read the word problem. Now I'm going to go through here and read everything in this word problem. The fastest moving tectonic plates on Earth move apart at a rate of 15 centimeters per year. Scientists began studying two parts of these plates when they were 30 centimeters apart. Write a linear function that describes the movement of the plates over time, then make a graph to show the movement over 4 years. Now, are the important words circled? So let's go through that and circle some important words. As I go through this one, the first one I see is the number 15. The number 15 that is an important word, and then centimeters per year would be the next thing I see, with per usually meaning to multiply. The next important word I see is began. Began tells me that they started somewhere, not that they started at 0, but that they started somewhere. And where they began is actually at 30. They began studying when these were 30 centimeters apart. So that tells me where they started off here. Next, apply the steps you chose to solve the problem. Well, remember I said that per means times. We're going to multiply by 15. And began tells me where they started. So I'm going to create a table here. Let me actually take that one off for just a second. Create a table here where I have my input, or my x, my rule, and my y. Remember I said 15 means I'm going to multiply, or the per means I'm going to multiply by 15. And 30 is where they started. So I'm going to add the 30 to it to begin with so that I show that they started at 30. Now if I plug in numbers here, and again I get to choose those. So the first number I'm actually going to choose is 0 because that shows where they started in times 0. 15 times 0 gives me 0, plus 30 gives me 30. So my first point would be 0, 30, even though I didn't have a column here for my ordered pair this time. My next point I choose is 2 because I am spanning over 4 years and I only need 3 points. So I'm going to go halfway in between 0 and 2. So 15 times 2, which is my rule, is 30. Plus 30 gives me 60. Next number I'm going to choose is 4. 15 times 4 gives me 60, plus 30 gives me 90. Next, I'm supposed to verify my answer. Is it reasonable? Does it make sense? Well, this actually does make sense because because of the fact that it would make sense if this is 60 additional centimeters or 60 centimeters further apart, since we started at 30. Eliminate wrong answers. Well, in this case, it's not a multiple choice answer, so I don't have any wrong answers to eliminate. Now let the answer stay or rework the problem. Now it looks like I've got it right this time, but I might have to rework it next time. Now it does say to graph over the next 4 years, and my unravel was in the way, so I got rid of that. Let's graph this first point. My first point was 0, 30. Remember, the x always comes first and the y comes second. So 0, and then I'm going to go up 30 and put a dot there. My next point is 260, so I'm going to move 2 right on the x-axis and then move up to 60 and put a dot there. The next point is 490, so I'm going to move 4 over on my x-axis and move up to 90 and put a dot there. And again, just like on the last one, can you notice that there is starting to look like there's a line here. So I actually put a line connecting those points. Great way to do this if you're scared and you want to make sure you have a straight line. Your book makes an awesome straight edge since most people do not have rulers or some other form of a straight edge at home. That spine of your book makes an awesome straight edge, or even just the side of the book makes an awesome straight edge. Now, I want you to notice something about these x and y axes, or this input and the output. Notice that quite often the output, or the y, often depends on the input, x. So y is called the dependent variable because it depends on what x is. And x is called the independent variable. And it's really neat as you come to see these things, getting ready to move into pre-algebra and algebra 1, how these things all come together and makes a really nice picture.